Okay, so let us start. Unit number 1 of chemistry in senior 5 is called Introduction to Organic Chemistry. Okay, so by the end of this unit, the student will be able to explain the following points. Okay, to classify organic compounds as aliphatic, alicyclic, and aromatic. Organic compounds are classified into the three classes. The first one is aliphatic compounds. They are the ones which are chains. They may be chains or they may be branched. Okay. Alicyclic, they are also the compounds which are cyclic, but they are derivatives of aliphatic compounds. Okay. It means that they are not aromatic because they don't have carbon-carbon double bonds in the form of resonance. They may have one double bond or two double bonds, and in that case they are alicyclic. But if they have three double bonds in the ring, in that case they may be classified as derivatives of benzene, and they will be aromatic. We will see some examples. So by the end of this unit, you will be also able to determine the different formula for the compounds, for organic compounds. We will calculate different types of formula: empirical formula, molecular formula, structural formula, okay, and even molecular formula, okay, molecular formula, empirical formula, structural formula, and then we will analyze this formula. Okay, so we will also be able to describe the common functional group and related them to the homologous series. Okay, we know that organic compounds are classified in different homologous series depending on their functional groups. Okay, we will also identify how we can name the organic compounds. Okay, IUPAC rules to name different organic compounds. Okay, then we will also be able to describe the isomers of organic compounds. Okay, so now if we start by definition of organic compounds, we say that organic compounds are defined as the study of compounds made mainly by carbon and hydrogen atoms, and sometimes oxygen, nitrogen, and phosphorus or sulfur or halogen atoms. Means that we can have a hydrocarbon chain made of carbon and hydrogen. That one is organic compounds, but we can have derivatives of this one where one hydrogen atom is substituted by halogen atoms, nitrogen, oxygen, sulfur, and so on. Okay, so now we have three categories of compounds that we study in the chemistry. The first one is organic compounds. The second one is inorganic compounds. Okay, the first one, which is organic compounds, is different from the second one, which is inorganic compounds. For example, in terms of bonds, organic compounds have covalent bonds. They are covalent molecules. But in inorganic compounds, the bonds which are there are ionic. Okay? So the covalent molecules are always found in organic compounds, but ionic compounds are in inorganic compounds. Okay? So when we are determining the compounds which are covalent, we analyze the difference or in electronegativity of the atoms which are making a compound. Okay? For example, in carbon, in the bonds where carbon is bonded to hydrogen, okay, we analyze the variation of electronegativity or electronegativity difference between carbon and hydrogen. Okay, so if that difference in electronegativity is less than 2, the compound will be covalent molecule or covalent compounds. But if the variation of electronegativity is greater than 2, that compound will be classified in inorganic compounds. We will see these bonds, how we can differentiate them. So, in terms of the classes, in organic compounds, we have alcohol, aldehyde, carboxylic acid, amine, ketones, amide, nitriles, esters, ethers, acid, anhydride, and so on. These are different homologous series. Okay, but in organic compounds, inorganic, we have acids, base, and salts. Okay, so in terms of melting points, the melting point of organic compounds are low. Melting point and boiling point are very low because these bonds are not very strong and the intermolecular forces are weak in organic compounds. But in inorganic compounds, because some bonds are ionic and some of them have the metallic character, the melting and boiling point will be high. Okay, so in terms of solubility, solubility in water is low in organic compounds. Okay, it means that some of them are soluble in water, but the solubility is very low because the compounds sometimes are nonpolar, or the nonpolar portion or nonpolar side chain is very large. In that case, the compound will not be soluble or the solubility will decrease. Okay, so but the solubility of inorganic compounds in water, it is high, but in inorganic solvent is low. So the solubility of organic compounds in organic solvent is also high. Okay, for example here, if we take for example alcohol and we consider it as the solvent, this one can dissolve, for example, alkanes. For example, the paraffin may be soluble in alcohol, but not soluble in water. Okay, because alcohol will be organic solvent. For example, if we dissolve some alkanes in ether, they will be soluble, but some of them may be not soluble in water because they are organic compounds. So, organic compounds they are volatile and flammable. For example, if they have the low molecular mass, they may be volatile. If the substance is volatile, it means that the particles of this one can leave liquid phase to vapor phase. Okay, sometimes you can smell their odor. Okay, for inorganic compounds, the volatility is very low and they are not flammable, they are inflammable. Okay, so in organic compounds, reactions are generally slow. Reactions goes slow, but in organic compounds, reactions are generally fast. Okay, in organic compounds, we have many isomers. The compound may have different isomers, but in inorganic compounds, the isomers are fewer. Okay, we will analyze each step by step. Okay, so why study organic compounds are organic chemistry as a separate branch? Okay, the first one we say that we study organic chemistry as a separate branch because of large number of the compounds. They have different compounds which are in organic compounds. So this one require to study organic chemistry separately because of large number of organic compounds. So number two is build of relatively few elements. So there's the compounds which are organic are made of fewer elements: carbon, hydrogen, sometimes carbon, hydrogen, and halogen, oxygen, sulfur, nitrogen, and so on. There are fewer elements. So number three is unique characteristics of carbon to undergo catenation. So catenation is the property of carbon to make double bonds where one carbon will be connected to another one. It is a unique character of carbon atom, okay, where one carbon may bond to another one and they form a chain. Okay, we will analyze these types of covalent bond which are formed by carbon in the long chain, for example in polysaccharide, proteins, polyester, polyamide, and so on. We'll see these examples. So number 4, we say that they exhibit isomers, many isomers. We have many isomers in organic compounds. So this one is also the reason why we have to study the organic compounds as the separate branch, organic chemistry as the separate branch. So number 5 is the functional group as the basis of classification. So when you want to classify organic compounds, we have to classify them in their homologous series. So to classify compounds in homologous series requires to know the functional group of each class. Okay? For example, if you wanted to say the compound is alcohol, so the compounds or the molecules of that class of that homologous series will have the same functional group. Okay? So we say also that they are combustibility. They have the combustibility. It means that many organic compounds are combustible. Okay? It means that we can burn them in the presence of air. For example, you know the fuels. For example, the fuels that we put in the car so that they can move. Okay? So this combustibility is the ability of these organic compounds to be burned in the presence of air so that the engine from the car can produce the energy. Okay? So another one is the nature of chemical reactions. Okay? So they have different types of reactions. We have different types of reaction in organic compounds. So these are the reasons that we have to study organic chemistry as the separate branch. Okay. So now we have importance of organic chemistry. So organic chemistry is made of the compounds which are made of the substance that we have in our daily life. It means that many of them are from the plants and the animals. Okay, so the reason why we can also have the organic chemistry application in our daily life. For example, in the food, the composition of food, you know the starch which is found in the crops from the plants, fat, protein, vegetables, fat is from animals, protein from plant and animals. So, for example, in crosses, okay, when we are wearing the crosses, some of them are made of cotton. Cotton is organic compounds, or nylon, dacron, and these are also the derivatives of organic compounds. So fuels, for example, when we are cooking at home, we can use the gas, we can use petrol, we can use some fuels like diesel oil, kerosene. Okay, these substances are organic compounds. So dyes, different types of dyes. These are also derivatives of benzene. So cosmetic substance, for example, the body lotion, okay, the soap and the detergents, these are organic compounds. In medicine, different medicines are made of organic compounds because they are made of plants and animals. So drugs like morphine, cocaine, you will see the formula of all these substances. So stationery, for example, pencil, paper, writing ink, okay, insecticides, these are also applications of chemistry. Okay, they are derivatives of chemistry. So in industry, different industry which are manufacturing food, pharmacy, pharmaceutical substances, okay, manufacture of dyes, explosive, alcohol industry, for example, in fermentation, soil, fertilizer, petroleum industry, and so on. All these products are made of by application of organic chemistry, by the use of organic chemistry. So we can also use this one in the study of life process. For example, the composition of human body is made of proteins, there are vitamins, enzymes, hormones. All these compounds are made of the organic chemistry. So today we are going to stop here, and the next time we will continue by classification of organic chemistry. Okay, so what you have to know is to make the summary. Now we can have the summary of what you have studied. We have to define organic chemistry. Okay, we know that it is compound which is made of carbon, hydrogen, and it can also have other atoms like halogen and so on. Okay, we have differentiated organic compounds and inorganic compounds. We have seen these differences. So we have also studied the reason why we have to study organic chemistry as a separate branch. Okay, we have seen that they have a large number of compounds. Okay, we have seen that they are built of relatively fewer elements, carbon and hydrogen, sometimes with other hydrogen. So we have seen the catenation, which is the properties of carbon to make a chain. Carbon atoms can make a long chain by using their catenation property. Okay, they exhibit different isomers and they are classified by the basis of the functional groups. We have seen that they are combustible. It means that we can burn them, and they have many types of chemical reactions. Okay, so in terms of importance, you have seen that there are different applications of organic chemistry. For example, in daily life, we have seen that our food, our clothes, fuels and dyes, cosmetics, and soap, medicines, drugs, all these are made of organic chemistry. So we have also seen that in industry, different products like food, pharmaceutical products, explosive, alcohol, soil fertilizer, petroleum industry, and so on, they are made of organic chemistry. So, and we need life process. When we are studying life process, all the composition of human body is organic chemistry. For example, you have seen that the vitamins, enzymes, proteins, hormones, which are making the human body, are made of organic compounds. So now we are now stopping here. Then now we can say that we will continue by classification of organic compounds. We'll do many exercises and continue to follow this lesson. Then we will continue and we will finish all organic chemistry of senior 5 unit by unit. We will do many exercises and we will continue next time. Thank you very much. Thank you for following. continue to subscribe and continue to work with us in this platform of chemistry.